Math lesson number 47, parallel lines cut by a transversal. So let's have this one. The parallel lines are lines that will never intersect. So in this figure, the parallel lines here are line L and line M. Because when you're going to extend line L and you extend line M, they will never intersect. So line L and line M are the parallel lines. Now this line N, which cuts the parallel lines, is called the transversal. So transversal is a line that cuts the parallel lines. So line N is the transversal in this figure. So if parallel lines are cut by a transversal, then 8 angles are formed. So we have angle 1 here up to angle 8. So 8 angles are formed. And we have also pairs of angles formed. And we also have postulate and theorems. Now, let's have the first postulate. If two parallel lines are cut by a transversal, then the pairs of corresponding angles formed are congruent. So that's the postulate, meaning to say we don't need to prove this is already true. So the pairs of corresponding angles here are angle 1 and angle 5. So as you can see, angle 1 looks the same as angle 5. So they are corresponding angles. 1 corresponds to 5. Angle 2 corresponds to angle 6, angle 3 to 7, angle 4 to angle 8. So meaning to say there are 4 pairs of corresponding angles that are formed when parallel lines are cut by transversal. And take note that these corresponding angles are congruent. So that's the postulate. And we will use this postulate to prove some theorems related to parallel lines cut by transversal. That's the first theorem. So the first theorem is if two parallel lines are cut by transversal, then pairs of alternate interior angles formed are congruent. So that's the first theorem. So what are the alternate interior angles here? So we have angle 3 and angle 6. Take note, alternate interior. So angles that are alternating. This one is on this side and 6 is on the other side, alternating. And interior, meaning inside the parallel lines. So these are the parallel lines. And as you can see, 3 and 6 are inside the parallel lines. So they are called alternate interior angles. And according to the theorem, alternate interior angles are congruent. So angle 3 is congruent to angle 6. Angle 4 is congruent to angle 5. So those are alternate interior angles. Now, because this is a theorem, so we need to prove this if this is really true. So we need to prove that angle 3 is congruent to angle 6 and angle 4 is congruent to angle 5. So first, angle 3 is congruent to angle 7. So angle 3 is congruent to angle 7. Corresponding angles postulate, the one that we had before, no? The postulate, the corresponding angles postulate. Next, angle 7 is congruent to angle 6. Angle 7 is congruent to angle 6 because angle 7 and angle 6 are vertical angles. And vertical angles are congruent. And we name that as vertical angle theorem. Now, as you can see, angle 3 is congruent to angle 7. Angle 7 is congruent to angle 6. We substitute 7 here by angle 3. And as a result, we have angle 3 is congruent to angle 6. Substitution. And that's the first that we need to prove. Next, angle 4 is congruent to angle 8. Again, corresponding angles postulate. Angle 8 is congruent to angle 5. Vertical angle theorem. Next, angle 4 is congruent to angle 5. So we substitute angle 8 by angle 4. And that is substitution. So we proved angle 4 is congruent to angle 5. So that's the proof of alternate interior angles theorem. Next, number 2, or theorem number 2, if two parallel lines are cut by transversal, then pairs of alternate exterior angles formed are congruent. So take note, earlier we had alternate interior, now we have alternate exterior. So what is alternate exterior? So when you say alternate exterior, angles that are alternating. So for example, angle 1 and angle 8. Angle 1 is on this side of the transversal and 8 is on the other side of the transversal. So they are alternating. And exterior meaning outside the parallel lines. So angle 1 and angle 8 are outside the parallel lines. Next pair is angle 2 and angle 7. So angle 2 and angle 7 are alternate exterior angles also. And take note, according to the theorem, alternate exterior angles are congruent. So angle 1 is congruent to angle 8, angle 2 is congruent to angle 7. And once again, because this is a theorem, we need to prove if angle 1 is really congruent to angle 8 and angle 2 is congruent to angle 7. So first, angle 1 is congruent to angle 5. Again, corresponding angles postulate. Angle 5 is congruent to angle 8. Vertical angles theorem. And then angle 1 is congruent to angle 8. Substitution. So we proved the first congruence. Next, angle 2 is congruent to angle 7. We need to prove this. So first, angle 2 is congruent to angle 6. 2 is congruent to 6. Corresponding angles postulate. Angle 6 is congruent to angle 7, vertical angles theorem. And again, we substitute this 6 by 2. So we have angle 2 is congruent to angle 7, substitution. So again, we proved angle 1 is congruent to angle 8 and angle 2 is congruent to angle 7. So that's the proof of alternate exterior angles theorem. Let's have the third pair of angles and the third theorem. If two parallel lines are cut by a transversal, then pairs of same side interior angles formed are, take note, not congruent but supplementary. Supplementary. So meaning to say, when we say supplementary, the sum of the two angles is, the sum of the measures of the two angles is 180 degrees. So what is same side interior? What does it mean by that? So when you say same side of the transversal. So for example, angle 3 is and angle 5. So again, angle 3 and angle 5. Same side of the transversal and inside the parallel lines. So the parallel lines is this one and this one. And the parallel lines are line L and line M. So inside of that, we have angle 3 and angle 5. Same side of the transversal line. Next, angle 4 and angle 6. Same side also. And as you can see, angle 3 is acute and angle 5 is obtuse. So they are not congruent. They are supplementary. So take note, guys, that same side interior angles are supplementary. So let's prove this theorem. So we need to prove that angle 3 plus angle 5 is equal to 180 and angle 4 plus angle 6 is equal to 180 also. So first, angle 3 is congruent to angle 7. 3 is congruent to 7, corresponding angles postulate. Next, angle 7 is congruent to angle 5. 7 is congruent to 5. As you can see, 7 and 5 form a line. So they are called linear pair. So two angles that form a line is called linear pair. And linear pair is a pair of angles that is supplementary. Meaning to say the sum of the two angles is 180. So angle 7 and angle 5 is equal to 180. So definition of linear pair. Now we substitute this 7 by 3. So angle 3 plus angle 5 is equal to 180 by substitution. So we prove the first part. Second part, same process. Angle 4 is congruent to angle 8. Corresponding angles postulate. And then angle 8 plus angle 6. 8 plus 6 is equal to 180. Definition of linear pair because 8 and 6 form a line. Now, angle 4 plus angle 6, we substitute angle 8 by 4. And as a result, we have 180, and that is because of substitution. So we prove the second part. Angle 4 plus angle 6 is equal to 180. So that's the proof of same side interior angles theorem. Let's have the last pair of angles. Same side exterior angles. So we have if two parallel lines are cut by transversal, then pairs of same side exterior angles formed are supplementary. So same side exterior, same side of the transversal, just like 1 and 7, and outside of the parallel lines. So 1 and 7 are examples of same side exterior angles, and they are supplementary. So they are not congruent. They are supplementary. So the sum of 1 and 7 is 180. The sum of 2 and 8 is also 180. And let's have the proof of this theorem. So angle 1 is congruent to angle 5. 1, 5. Corresponding angles postulate. Angle 5 plus angle 7 is equal to 180. 5 plus 7, 180. And that's because of the definition of linear pair. So 7 and 5 form a line. So they are linear pair. Now we substitute this 5 by 1. So angle 1 plus angle 7 is equal to 180. Substitution. So that's the first part. Second part, angle 2 is congruent to angle 6. 2 and 6, corresponding angles postulate. Next, angle 6 plus angle 8 is equal to 180. Definition of linear pair because angle 8 and angle 6 form a line. And the measure is 180. Now, we substitute this 6 by 2. Angle 2 plus angle 8 is equal to 180 because of substitution. So we proved the second part. And that's the proof of same side exterior angles theorem.